We're going to move away from web development a little bit, and we're going to be diving into data science. We're going to be checking skin for the next 10 minutes. Let's welcome Steve on stage.
So my name is Steve. Is the volume okay? At the back, great. Louder, louder. Okay. So for our project Skin Checker, we wanted to use data science to help reduce the impact that skin cancer has. This is a team effort, and I could not have done it without my boys, Maxi, my son Kai. He's 19 years old. 19 years old. And Peter, he's not my son, but he could be my son-in-law. He could be my son-in-law. So thank you, boys. They're fine gentlemen. They're great. Skin cancer is a global issue. Every year, there are more than 7 million cases of skin cancer and 100,000 deaths. There are 3 main types of skin cancer: BCC, SCC, and melanoma, being the most dangerous and malignant. Based on your ethnicity, if you're from Europe, America, England, Australia, 1 in 5 chance that you will contract skin cancer in your life. It is a growing problem. Every year, in the next 20 years, cases are expected to double. The older you get, the higher the risk profile. So it is really difficult, though, to accurately monitor and track your skin health. It's hard, it can be costly to get checkups. It requires specialist care and equipment. It may not be accessible in your area. We have built an app that allows a user to simply take a photo of their skin. We process that image using deep learning, and then we classify it and allow the user to keep track of their skin health over time. Kai is going to tell you how we did that.
All right, thank you, Steve. So this entire thing works on the base of a model. Our model takes our image and does a little pre-processing on it by first reviewing it, kind of looking for any special features, edges, anything that it can find, before then compressing it and feeding that compressed image into a convolutional neural network, which will then hopefully give us a correct prediction of if it's melanoma, a BCC, SCC, or benign, i.e. your common mole or something unharmful. This, however, is made kind of difficult by there being over 50 different skin diseases that all kind of look very similar, and even if it's not a disease, it'll look really similar. So just as a good example for this, you can look at the very dangerous melanoma, and this is kind of like some outlines that are overlaid, and over there the nevus, which is your common mole, which everybody probably has somewhere on them. And if you look at the outlines of them, they look really similar to the human eye. So really difficult to tell what is the danger here. And that problem is not only there for us humans, but will also persist for the computer. Peter is going to explain a little bit more about the stats of our model and how that all worked out.
So first of all, let's talk about the accuracy. So the model right now achieves a 70% accuracy on the overall predictions. So in comparison, if you go to a specialist, do a complete medical checkout, you're going to reach a percentage of 95% accuracy. Well, however, our model serves as a preliminary scanning. So it's good in the sense that it's low cost, it's readily available, and you can get the result within 30 seconds. And so some extra features for our model is that it is aimed to pick up every single cancer risk, rather than having some cancer risk being undetected and left alone. However, our model still have some shortcomings. The first one, which is the thing we want to do, is to pick up every single skin cancer risk, which the model still haven't done it perfectly. So right now, say the model predicts you as a healthy guy, but in reality, you still got a 1 in 10 chance that you actually got a skin cancer. And the next thing is about the false alarm issue. Say if the model gives 10 alarm to the user, on average, 2 out of the 10 alarm the model gives is actually a false alarm, aka the user doesn't have a skin cancer problem. The third one, which is a minor one, is that the model doesn't pick up the correct cancer type. So say the model, even if it pick up the cancer risk, in 2 out of 10 chances that it's going to pick up the wrong cancer types. So right now, next, I'm going to ask my teammate to show how things work in reality.
So let's take a look at the application, shall we? Here it is. We built our front end with Streamlit and our back end with Docker, Big Cloud, and artifact registry. Sorry, I'm a little nervous, but we can handle this. Okay, so let's take a look. So we have two applications here. We have scan and score, and we have track and monitor. So let's take a look at skin check. Skin check is quite a nice feature because it allows the user to track a mole over time with an associated image. So let's take a look at a image of melanoma from a data set that we have. So hopefully this will predict as malignant. So let's press scan and record. Thank you, Steve. And as you can see, it is predicted as malignant. And so between these two probabilities here, it actually incorrectly categorized as melanoma. So I brought this up particularly to kind of make a note as to what Peter was explaining. So the model does have trouble categorizing between the two, well, between all of them, but in particular these two, and has misprobabilized as, or miscategorized as BCC-SCC. But this is just something we'll work towards improving in the future. So let's try one more. And this is an image we took earlier of Steve's arm. And he still has his little smiley face here. And so hopefully this image will be categorized as benign. So we'll enter a message, which we'll be able to see a little bit later. And we'll scan and record. And as you can see, it is correctly categorized as benign. So, thank you. Yeah, we're quite proud of this. And let's go to data records. And as you can see here, it's really nice that our app is able to help the user track the images that they've uploaded over time, just to keep their health in mind and really monitor for anything that might come up into the future, and use the recommendations to make an action that we assess as applicable. So thanks, and I'm going to pass the mic off to Steve to finish this off. Thanks.
Thanks, Maxi. Firstly, just wanted to say thank you, everyone, for your attention and applause and support. Secondly, I just say thank you to Sylvain and the Wagon for hosting tonight and putting on the show. Thirdly, just like to say a few acknowledgements to, say, Jan, Mark, Cedric, Yusuke, Andre. Without you guys as TAs and teachers and support, we wouldn't be here, and you helped us on the journey, and it means a lot, so thank you so much for your help. Thirdly, thank you. Fourth, did I say three already? I can't remember. To my team, the boys, the best, I love yous. To the classmates, 1809 Data Science, you guys are incredible. It was a great ride, great to be on the journey with you. To everyone here, pat yourselves on the back. You all deserve a round of applause too. Thank you.
Okay, I think we're ready to dive into our next pitch. Let's welcome Arisa on stage.